At least this hour, these 2 hours, 1 hour and a half, introduction of stress analysis. You should all have this. Let's start. خلاص yes. Okay, now, fine. Okay, let's make fast reviews about yesterday. Yesterday we found that you should put all inputs of your file, data, specifications, okay, and click apply. Okay, all this data will be automatically input to drawing in your default table that you will make. Okay, I need not today, maybe today Sunday, yes, tomorrow inshallah, we will stay together, okay, with Mr. Khaldoon, and we'll create a table. Okay, you can use it here as your template drawing. Alright, we will create it together, okay, and I will give you to put it on server, and I will show you how can server can be connected with all computers, or meaning that any computer can get this file and you can open it together at one time, no problem. Alright, but today we'll go to something very important. We discussed yesterday that we will show something called stress analysis. Okay, stress analysis. Anyone can remember about this discussion? What's the stress analysis?
Regarding the weight, materials.
Yes.
Calculation of
Good. Stress analysis. Now, this is a door and this field. Okay. The application only opening and closing. Okay, haven't any extra loads. Okay, this part doesn't carry something with 1 ton, 2 ton, 3 ton. Okay, this means that this application only for opening and closing. Alright, you may not need to make this 2 millimeters sheet metal. You can save material with 1.5, for example, 1.2. Okay. So how can decide that you need 1.2, 1.1 through stress analysis? Okay. All right. First thing, before starting, we should know what's the stress analysis in general concept. Stress analysis simply good a calculation of loads. So now, for example, if this a beam, this part is a beam, okay, not door, and I will put it like that here, okay, and I will affect at the middle وليكن 100 kilogram. Okay, this 100 kilogram may affect bending and may not. Okay? Okay. In stress analysis, we put all conditions in computer to the part. Apply material, it's very important. And apply the point of fixations. I fix it here from this point and this point. Okay? Apply load. and load position. I will apply load here. I will apply load here. This load distributed or concentrated. Okay? And what about this load? In kilogram, 100 kilogram, 200 kilogram amount of load. Okay? And you get results. Alright? Simple thing now? It's okay? Clear?
Yeah.
Okay. Now, if we will get this door, really, charging station. And open this port. Okay. To start with stress analysis, now we have a door. This door. Okay. First, to activate your simulation module on SolidWorks, go to these add-ins and select SolidWorks simulation. Select this box and this box and click OK. You will find this menu has been added. Okay. First, now you have the part. Should identify the material. Select the correct material. It's very important. For steel that you use here, you will select this type, because this steel called ST37. ST37. Okay. And this the DIN code S235GR. Second, I will need to make study. We will use only this one, static. Okay. First, what's the difference scientifically between static load and dynamic load? Anyone know?
Static is fixed, dynamic is moving.
Yes, it's the general name. Sure. Okay. What's the difference scientifically from your point of view? Closed? Yeah. They're open, click OK. Pop. Electrical cable may have problem. Okay. The difference when you have a beam or door. Or beam, okay, if you have a beam like that. I see that you work with this type of beam. You know this type of beam? Working with it, okay?
Yes.
You have here.
This one.
This one. Okay. Now, if this beam from side view or front view, this beam will be fixed from here with bolts and from here with bolts and have all L specific lengths, okay? And you have load concentrated or distributed accordingly. Okay? This load called static, because you will put a load on a fixed beam, okay? And only the effect you need to know, the effect of this fixed load on beam. Okay? Is static calculation. What's dynamic calculation? Dynamic calculation, if you have a construction, okay, and this beam have 4 wheels, you have a structure and they have 4 wheels, and this structure running in street, okay? And when the structure running on the street, you need to know some forces about the reaction of asphalt, of street, okay, on tires and on structure. In this way, you are on dynamic because you make calculations for movable body, okay, not fixed body, okay. So dynamic way, it's more difficult than static. Static, all rules and equations simple, no problem here, because you have static loads and static values. But in dynamic, you have something more. Dynamic, we will discuss it, but not this session, not this part, okay? Next season, about 2 months, when I will come to you, inshallah, again, you will see this dynamic, okay? We can discuss it not in more details, but in details that you can support your work, okay? All right. This door, we need to make some calculation of it. We need to know if this door, when opening and closing, okay, can be bending like that or no. For example, okay, let's check. You have these factors. First, material, okay. Second, not need this connection, fixer. Right click, fixed geometry. Check your faces that will be fixed. For example, you will fix this one and fix this one. Okay. With green sides. Now fixtures have these 2 faces. Okay. External loads. The load. Right click. We need the force or pressure if you have. For example, force. Apply force on this face. This arrow. Apply force on this face. So I fix it. From these points, and I'll apply loads like that. I fix it from these edges, and we'll apply load from here. Okay. This load can be measured in Newton or kilogram. If you need kilogram, change the unit to metric, and will be kilogram force. Apply it with kilogram. Your hand force can't exceed 30 kilograms. In this way, can't exceed 30. That is very large. Okay. For example, 30 kilograms. And okay. Finished. Right click on static and run. Yes. Really not bended, but this is called a simulation. What's simulation? Now, this is not the real bend. This is not the real. This is zoomed with 40x. This effect, this is a real effect, yes, but zoomed in 40x, 40 times under microscope. If you will under microscope zoom it 40 times, you will find this bend. When I will do something like that, maybe have a pen, but this pen very micro small, not small, micro small. But when you will large it on a tools like microscopes, like magnifiers, something like that, for 40x, you will see the pendant. Okay, so This graphic, just a graphic, okay, which show you the effect, but you have a value. Your evidence here are values, okay. So displacement, this main value that we use, okay. Displacement. What's the meaning displacement? Displacement, the real displacement point. How bending amount. If we get line like that, this guy measure the bending amount. Okay, this displacement. This meaning that this point has the maximum displacement. Maximum displacement. But which value of displacement we need? We can try. Right click, change this type of text. Right click setting on displacement and go to chart options, change it to general. 0.2 millimeter, nothing. 0.2 millimeter. This means that this red area displaced from the main surface by your force 30 kilogram. It's a very large force with 0.2 millimeter. Okay, so if you will change this 30, right click, edit definition, and change this to normal force 10. This normal human force, right click, run. 0.06. Displacement was 0.06, less than 0.1 millimeter. This means that this material very costly to use it in this project. So we can reduce the material. Right click, go to here model, and this static, go to model and change 1 millimeter. Let's first do something important. This 2 millimeter, evaluate, measure. Mass 7. This is economical. This is economical way also, not only technical. Okay. This is real calculation, real job you have to have. Seven, 1, 5.91. So this kilogram. Sorry. Okay. Let's convert to 1 millimeter. And check. How? 359. What? 59. Point. Sorry, gram. 50% material cost. Let's check. Static. Just click run again because you modified the thickness. Okay, but all factors are fixed. Okay, like fixers and loads. Okay, no change. 0.3 millimeter. Also safe. What's the 0.3? If you get the caliber and open it on 0.3, you will not see nothing.
What is the maximum for the maximum, sir?
Maximum deflection, I will explain this because you will know it from stress, and I will explain to you how to identify that you are in the maximum or no. Now I will go to this point, but need some concentration from you. Okay, displacement 0.3. So you can use it from 1 millimeter. Why 2? Okay, let's try. make economical check. How many units you have in your order? How many doors? You know?
23 units.
No, 23 units, but each unit have a lot of doors.
Yes.
A lot of these small doors. How many?
200. 2,300.
2,000 what?
23 times 10. 1 unit is 23 times 10. So 230.
Each unit have how many doors? Each unit?
10.
10. And you have how many unit? Big unit?
23. So
23. 10 by 23?
230.
230. This means that you have 230 doors. Okay? 230 doors. Let's check. 230 by 715.91 will need 1,064.7 kilogram. $164.7 kilogram on the first load, the first weight thickness, okay? Second thickness, we have divide 2. Kilogram. Economical. If your kilogram here with $1, okay, this means that you have 82.3 dirham saved. It's only indoor. Only into these small doors. Okay, may this can be applied on total unit. Okay, so you have to save your money on these calculations. You can save money. Okay, save production, save materials with these calculations. Small calculation, no time, nothing, but save money. Okay. Second point, how, like Arnold, like question of Arnold, how can identify that 0.3 is okay or not okay? Okay. Depend on application first, meaning that you have a door, okay, and this 0.3 in this size, you need, from this application, only small user. Just opening and closing will not affect any loads. Okay, so 0.3, if you can measure it with your sense in caliber, nothing would affect the problem. So you have a sense in these small projects. But if you have a larger project, like for example structure, and you have a pending, you found that sure that you will have a pending. Now, each one of employees here, when working on this structure, have a pen, but you don't see. There is a pending, but don't see. It's pending with small values like that. Okay, how can I identify that these values is allowable and accepted or no? Okay, let's see something together. First, this depending on some values in material. What's the physical properties of material that can achieve these points? Now, all scientists worldwide from years ago made a lot of tests, a lot of material tests, okay, and have standard table with some factors of steel, specific factor for aluminium, specific factors for stainless, specific factor for plastics. Okay, what these factors and how can we use it? First, called tensile test. Let's check.
The tensile test. First test, material with yield point phenomenon. In the first tensile test, a plain carbon steel with yield point phenomenon is to be tested. This is the test piece.
First. You see this one? This is a part, this is a labor part. This is a part would be applied on it the test. Okay? What is part? Now we're using steel. Okay? They bring the same type of steel and fabricate it with this shape. Okay? And this shape will be installed in a machine now that you saw, and you will see. Okay? This machine will fix it from this side and this side. Straight. Helically. Okay? After that, this machine will make a tensile. Tension. Will tensile it. Okay? At specific point, this steel will be cracked. At specific point, this steel will be cracked. This unit, this bar, will be cracked. Okay? Will be divided into two parts. Okay? So, on a machine, have something like digital or digital comparator. Okay? Show you the force while inside it. Okay? At the crack point, okay, the machine will stop and register the maximum force, okay, has applied to make this crack effect. Understand? Clear? This value that we need is a value of material. Okay, let's check.
Has a cylindrical test region with an original diameter of 10.
Have a specific diameter with 1 centimeter, for example. 1 centimeter. Should know the diameter.
Millimeters and an original gauge length of 100.
And specific length.
Within this test region, distance marks have been drawn at regular intervals. They help to visualize and measure the plastic behavior of the specimen. Using a hand control, the tester moves the upper crosshead into its correct starting position. Now we can place the threaded ends of the test piece in the lower and upper grips of the testing machine. In the next step, he swings the extensometer into its working position and checks that everything is correctly prepared. Then he selects all necessary testing parameters on the control computer. Ready. The test starts and the extensometer's sensor arms are carefully pressed onto the test piece. This way, the gauge length can be measured throughout the whole tensile test. The gauge length is displayed at the bottom right-hand corner of the screen. At the beginning, it amounts to 100 millimeters. During the tensile test, the test piece is slowly and constantly elongated with a standardized speed. The force that the test piece opposes to the imposed elongation is recorded and can be seen at the bottom left-hand corner of the computer display. The material behavior can best be observed in the force elongation diagram. The force F is being plotted upwards on the vertical axis, the elongation delta L towards the right on the horizontal axis. At first, the force rises rapidly. Force and elongation are proportional and form a steep, straight line in the diagram. In this area, the material behaves elastically. If the test piece were to be unloaded from this area, it would spring back completely to its original length. In materials with yield point phenomenon, the end of the area can be seen clearly. The plastic deformation starts abruptly and is accompanied by a sudden drop of force. If the test piece were to be unloaded now, it would not spring back to the original length, but instead show a permanent elongation. In the next stage of the tensile test, an almost constant force level with slight fluctuations occurs. Known as the Lular strain, through a certain strain, known as the Lular strain, the force increases again. The material opposes an increasing force against the imposed elongation. Its strain hardens. Up to the point of maximum force, the test piece is strained uniformly along its length. This means that the test piece gets longer and thinner, but keeps a cylindrical shape. As soon as the maximum force is reached, a neck begins to form at one point of the test piece. All further plastic deformation now only takes place at the neck, and eventually the test piece fractures there.
See? His effect? His neck. Okay. What? These are force. The force of tension. Okay? Machine record all forces during elongation. Okay? Now you have 2 points. Okay? The force of crack and the force before crack. Okay? But the force before crack divided into 2 types of forces. Something called elastic and plastic. What's the difference? Now, this pen. Okay, if you have any plastic ruler, please. See, this ruler can be twisted, see? Okay? But when I twist it, I apply a force. Now, I apply a force. After the move force, return to its place. Return to its location. Okay? So, the shape not deformed. Okay? This is called elastic. Okay? So, this means that this force, when applied on this material with this shape, this force only working in elastic zone. We are still on elastic zone. Okay? So, what's the elastic zone? Elastic zone, so when you apply a force on the material, and then when you remove this force, the material will return again to origin place, to origin shape. So, no change in material. Okay? You are safe. In this zone, you are safe. You are safe. Okay. So, if I will increase my force, increase, before crack, before this ruler to be cracked like that, you have a middle zone between crack and the elastic. This zone called plastic. Okay? What does mean? Mean that you apply force, and then when you remove this force, the part will not return to its position. Okay? So, this is called plastic zone. After plastic zone, you have the crack or fail. This means that these 2 parts for sure, this one part will be divided into 2. Will be cracked. Okay? So, you are okay? Clear? It's very important. So, when we get the structure analysis, any structure analysis on a beam or something like that, in plastic, acrylic, whatever, okay, to know the safe point from not safe point, okay, you should know this 0.3 millimeter in elastic zone or plastic zone. If this this 0.3 millimeter that we got here, okay, in elastic zone, so you are safe. You are safe. Okay? So if would be in plastic zone, you are not safe. Clear? Okay. Stress. This one is very important. Like displacement. From displacement, you can check the amount of deformation. You can check the amount of deformation. 0.3 millimeter, it's okay. Good. If it's good for you with sense, okay, will be go. If you know, if you need specific evidence, you should go to stress. And let's see what's the stress. Right click, edit definition, check chart option, change these values to normal value, sorry, floating, to these two normal values. And we'll change on also the unit, kilogram to centimeter square. See, here something called yield strength. Yield strength. What's a yield strength? Yield strength meaning elastic zone. This means the elastic value. The elasticity value of material. Okay? So, if your material, if your force arrive to this number, till this number below, you are safe. Below this number, you are safe. Below this number, you are safe. Okay? If your number has been measured than this one, not safe. So you should make the design. This means your design failed. Okay? Okay. Now, here he gave you the number of yield strengths of the material you are selecting. Now we selected ST37. It's our material we're using here. Okay? And this yield strength is the value of material. This means that this steel can support this number of yield after experimentally tests made not by us, made by some institutes. Okay? So if we need to check this one, you have here a red points. This red points means the maximum points of effect. Okay, it's the maximum effectiveness point. See this red one and check with the same red the value. 226.7. If you can compare this number with this number, you are very safe.
10%.
More than safe. 10%.
10%.
This number act 10% of this one. Okay, this means that you have a safety factor with 90%. If this number equal 10% of this one, this means that you have at least 90% safety factor. It's very good. So you can change this door to 0.5 millimeter, not only 1 millimeter. Okay? Let's check something else. Model. Three. Three millimeters. Go static. Run. Check stress. 60. And you haven't already red zones. if I need to check this color, okay, exactly, right click and probe. Sorry? Yes, probe. Okay? And click on points. You will read. Click on points. You will read the values. 60, 16, 0.5, 16.5. Less than 10%. Less more, 1%. This means that you have a safety factor with 99. This safety factor will affect cost. Cost equal money. Okay? Understand? Clear? It's very important. Alright. This stress and displacement. This strain, not important for us. Mainly using in dynamics and something else. Okay? Not important. Also we use it in static, but this is an advanced factor. You don't need now. Okay? You mainly you work on stress and displacement.
How can you make it that one as a report?
Report?
Yes.
Yes, okay, I will show you. Okay? Good. Clear?
Yes.
Okay. What the units of stress? Displacement, we know, millimeter, just deformation. With millimeter, length, just length measurements, okay? But in stress, you will find that kilogram force divided centimeter square. Anyone can remember me, what the centimeter square, millimeter square, what's this value? Area. When you asked me on a volume, remember?
Yes, you
Okay?
draw a box and
The box, surface area, okay, with centimeter square. There is a big rule, basics. Okay, that pressure equal what? Pressure. Now with my weight, I have a pressure on the land. Okay, I have a pressure on the floor. Okay, how can I calculate the pressure? Pressure P expressed with P. Pressure equal force, yeah. Force a big factor. Yeah. The force. Now we have a pressure. This means this pressure on table. Okay? If this table will be this pen have 100 kilogram. Okay? This 100 kilogram, when you mix swimming pools, okay, if you have something like small boats, you know it? Yes, sure. When this boat, if you are the same weight, if you will stand up on the pool in this one, you go down, yeah. And the same way, if you will sleep, you will not go down. Same weight. You are 100 kilogram, will be the same 100 kilogram. Okay, but where is the bottleneck? What's the difference between standing and sleeping?
the force, the balance of force.
Right, the balance of forces, the concentration of your force. Now, by force, I have 100 kilograms, but distributed on your length. You are sleeping, still distributed on your length. Okay? But if you have 100 kilograms, the same, but distributed on only one point. This is a pressure concept. Okay? So the pressure acts, the force, your force divided by area. Your force divided by area. Okay? Now, in cars, you know that you have a pistons. Okay? Sure that you know the pistons of engine. Okay? All nodes, okay? Piston. This piston will make a pressure of combustion in small room. Push piston down. This is the idea of engine. Idea of car engine. When you press piston down, okay, and this piston down and the another up, gets another down. The first one will be up and have a rotational motion. Okay. This pressure, this piston have a surface area. Have a specific surface area, okay, and have a force applied. This force applied divided this surface area affect pressure, equal pressure. So the pressure equal F divided by A. Okay, F in kilogram and A in centimeter square. So the final result will be kilogram force divided by centimeter square. Okay? All forces, all factors, materials, okay, tensile, yield, any factor, material, always you will see kilogram force divided by area. Force divided by area. Okay? When they made this test, inside test you saw, okay, they have a specific diameter, okay. The calculation would be what? At specific force, this diameter on this material has been cracked, okay. So the relation between the diameter and force. Diameter you can get from diameter the surface area. How? Surface area of a circle. Anyone know the rule of it? We discussed before the perimeter, total length. The total length is equal what? Anyone?
5 times diameter or 2 pi r.
Okay, yes. Circle, perimeter, total length equal 2 by r. Remembered?
Yes, sir.
Okay. The surface area of circle is a parameter. It's a parameter, okay? Meaning the total length. But the surface area equal by r square. By the same value, 3.14. Okay? And r square. The radius square. Okay? Clear? Clear or not? Tell me if I have a problem with this mathematical equation, I can accept it. Okay, I have a problem.
No.
It's okay? Alright? Now, he calculated this value based on what? Based on the diameter of bar has been tensile, okay, and the force has been applied. Okay? Clear? If you have for example a triangle, need the middle of triangle. This point shift, this point shift, origin intersect together. and get 50, for example. This part made it from plastic, acrylic, for example. It's acrylic. Okay. This material, if you will come to here, this specification, this standard specification of material, to which stress analysis base, okay, or founding its calculation on this, on that, right? Shell 3 millimeters, 3 millimeters, okay. Study, sorry, not this one. Simulate, study, static, and static. Fixtures, you will fix it from this face. And have an external load. The load will not direct force, will be torque. Torque. What's the torque? Like motors, rotation. Okay? This torque needs something very important in metric, and select your edge. Okay, and here select your axe, because of rotation you have to select the edge, okay, and the axe. Where can you get the axe? You may have here, we have it here, so we should go again to model and go to features here, sorry, reference, axis, create an axe. This an axe can check your resist point, it's very important, and the master plan, top plan. We create automatic axe, create OK, and bring it to here. Not important if here or any place, because just moving in X angle. Okay. External load, torque, this your axe. This is very important. Let's take axe. What? This one? This illustrates the face of rotation. The face that have the rotation. Now I will have rotation here, torsional, okay, and change the unit. Okay. Now, it's very important. This unit, not in kilogram only. Not in kilogram only. This is a torque. So, what's the torque? Torque of motors. It's expensive. Okay, can do. Okay. The torque can be defined scientifically as the moment of rotation. The moment of rotation. What's the moment? Now, when you change your tires in car, okay, you have the wrench. Change it. And when you need to make a very tight, what do? You get with a big bar and put it, and with your weight on it, okay, till tighten it, okay. How are you do that? This is a moment of rotation. So, if you have a box, okay, and you have an arm, you have an Okay? And you need this point fix it or have a resistance. Have a resistance this point. Okay? And you need not and you need to rotate this nut that already have, for example, an adhesive, have a big tightening force, whatever, okay, and to rotate this nut. So we will apply your hand will act a force here, okay, F, alright, and you will start rotating out this point, meaning that you have a virtual axe you don't see, act a radius of circle, act as a radius of circle, okay? What's the meaning of radius? Half of them, okay? Clear? Okay. Have a force. If you will increase this arm length to be here, for example, F2, and this L1, and L2. Increase this virtual axe. Okay? So, your force here, you don't need to create or to make a big effort. Just will be okay. And here, no, we need. What do we need to do? Why? Because this short length. Okay? Here you have a resistance. This resistance can be represented like that. You have a resistance. Okay? This resistance R. Now R are fixed. Okay? This R fixed. Fixed R. Okay? You need a force equivalent this R, okay, to start moving this nut. Okay? Clear? So now if you have R with a specific value X, R equal anything, okay? And now if you need to calculate the force you need, you will multiply this force by this length. The rule, moment M1, moment number 1, the moment. You know what the meaning of moment? Moment. Okay? You know it or no? Clear? The word moment? Not moment. Moment. Okay. Really, you know what does mean or no? If I will get and leave him to push this step. Okay. If you have a good moment, that means you can make it.
The conditions there.
Okay. If you haven't, you can't. So the moment, there is a big small difference between the force and moment. Small difference between force and moment. Force meaning the weight itself, the power, the weight, your weight. This weight of pen can be defined as a force. Just weight. Just one factor called force. Okay, just false. But the moment have two factors. Moment have two factors. Okay, the weight or force multiplied by length that we need to rotate. Okay, so the force of rotation, multiplied by this length will affect something called moment. Alright? Something. Moments. Now, you have a force, the force of the weight of your effect, okay, multiplied by the length, okay, can lift the stone. Okay, you know this application, we play with it, we are children, something, yeah, it's normal application, you know that? Okay, you know that? Normal application. Okay, so now if you have a big value, okay, have a water, okay, and this water you need to pull up. You will pull up with manovella. In Italian called manovella. Also in Arabic manafella. Okay, you need to apply, need to pull up. Okay, so you need to rotate. Alright? Yes, you need to rotate. Okay, you need to rotate. But when I need to rotate, should have a big arm. Because your force will multiply by the distance of this arm, will affect a force, will affect a moment. This moment can pull up this weight of water. Okay? Understand what's the idea? Okay? Clear? If you need to make a copy from this one, do it carefully. Can you make a copy? This your sorry, this your paper?
Yes, okay.
Sorry. Okay, so now you have this torque. This is called torque. This moment called torque. You can explain by moment or torque. Okay, this means that you have applied 10 kilogram weight, 10 kilogram with centimeter torque. With 1 centimeter torque. 10 kilogram will be supported on centimeter. If you this one. If this N1 equal 1 centimeter, okay, this means that you have a torque with F equal 10 kilogram with 1 centimeter radius. Okay, this is called torque. 10. Alright? Clear? Okay? What?
It's like physics.
It's physics. Not like this, it's physics. This book is physics.
I remember my Dali time.
Yeah. In schools, the basic of schools. In secondary school, or you get it in primary or in secondary?
College, university, bachelor.
University. You haven't eaten secondary school?
We have
You have
secondary school, college, then university.
Yeah. Your department was what in university?
I was
First in my college I have a subject of physics, but when I go to university, BSCS, I choose the computer field.
Computer.
Yeah.
Yeah.
BSc.
And you finished university with computer?
Yeah.
You finished with computer. Programming or computer engineering hardware or programming software?
Program.
Programming. So you know good about VBA?
Yes.
You know websites like that.
Yeah, website.
You're working with websites.
The language that was too difficult.
Yeah.
Dash include, converter, markup class.
You know about HTML5 or
Yes, sir.
you follow?
A little bit.
Yeah. With a copy in the whole book. All papers. I have 300 papers. We'll finish tomorrow. If you need to copy anything from this book, no problem. Okay? You will see the language in Italian, because we are not studying in Italian. Okay? But no problem. All the samples are okay. F called false and M moment, the same sample, okay? Because it's international. Alright. So here you have to reverse the direction of force. Now all rows will here, okay, you can reverse it if you need by clicking on reverse directions. If you know, don't click on reverse. Here, per item and total. What does it mean? It's very important to know. Now we have 10 kilogram force by centimeter. Okay, this is my torque. I need to apply. Okay, this torque I will apply on each item. Will have a 10 each item. Per each selection will get 10, but this 10 for all. It's very important. Change. The results will be changed completely, because it means if you don't know what's the difference between them and you have it per item and you need this number for all, this means that now for all you have 30. 10. Okay, but when you get it no totally, it means that your number are total. Okay, so okay, here will edge you can't apply normal force or torque on edges. It's okay, so I need to make it on faces. Okay, right click, run. Okay, you can displacement, right click, animate, reduce. Will give you the effect. Okay. Let's read, right click, settings, floating, on stress, right click, edit definition, chart, floating. Let's check these numbers. Now the yield of acrylic was this number, but we will change it to centimeter, not Newton. This number 458.8. Now the maximum that you have 4.3. You are very safe, very safe. Okay. Can you bring me a motor from storage?
Motor?
Motor of SPG motor. You have. I need one sample. I will show you something for torque.